You ever wonder how does the Earth go around the sun? We know that we go around the sun once every 365 days, but how does it actually happen? Is there some giant force pulling the Earth along this path? In this video, we're going to answer those questions and many more. So let's get started. The first thing that we should probably talk about is gravity. You may have heard that the reason why we stay on the ground is because of gravity. But did you know that gravity is also what keeps the Earth in orbit around the sun? To understand how gravity works, we need to learn about two very important things: mass and distance. Mass is basically the amount of matter in an object. The more mass an object has, the stronger its gravitational pull will be. Now, where do we feel this gravitational pull? Well, if we take a look at the Earth here and you are over here, then you will feel the Earth's gravitational pull at this distance from the Earth. However, as you move further away from the Earth, then you will feel less and less of the Earth's gravitational pull. And conversely, if you move closer to the Earth, then you will feel more of the Earth's gravitational pull. If we plot the strength of the Earth's gravitational pull against the distance from the center of the Earth, then we get something that looks like this. Now, if we take our friend the Sun and put it here, then anything that is close to the Sun will feel the Sun's gravitational pull, just like how you would feel the Earth's gravitational pull if you were standing on the surface of the Earth. But the difference here is that the Sun is way more massive than the Earth, so its gravitational pull is much stronger than the Earth's gravitational pull. If we take our friend the Earth and plot the strength of the Sun's gravitational pull against the distance from the center of the Sun, then we get something that looks like this. If we compare this graph to the previous one, you will notice that the strength of the Sun's gravitational pull is much greater than the strength of the Earth's gravitational pull. In fact, at any distance from the center of the Sun, the strength of the Sun's gravitational pull is greater than the strength of the Earth's gravitational pull. Now, you may be wondering, if the Sun's gravitational pull is always stronger than the Earth's gravitational pull, then why doesn't the Earth just keep falling into the Sun? Well, that's a great question. Let's go back to our graphs. Remember how we said that the strength of the Earth's gravitational pull gets stronger the closer you get to the Earth? Well, the same thing happens with the Sun. As you get closer to the Sun, the strength of the Sun's gravitational pull gets stronger. So if the Earth were to get closer to the Sun, then the Sun's gravitational pull would get stronger and stronger. And eventually the Sun's gravitational pull would be strong enough to pull the Earth into the Sun. On the other hand, if the Earth were to get further away from the Sun, then the Sun's gravitational pull would get weaker and weaker. So, the further the Earth gets away from the Sun, the weaker the Sun's gravitational pull becomes until it's not strong enough to hold the Earth in orbit anymore, and the Earth would fly off into outer space. So for the Earth to stay in orbit around the Sun, the Earth needs to be at just the right distance from the Sun. What's this distance? Well, it turns out that the Earth needs to be about 149.6 million kilometers away from the Sun. This distance is called an astronomical unit, or O for short, and it's defined as the average distance between the Sun and the Earth. Now that we know that the Earth needs to be about 149.6 million kilometers away from the Sun at all times, how does it actually achieve this? Well, it turns out that the Earth has a speed that keeps it in orbit around the Sun. This speed is called the orbital speed, and it's about 29.8 kilometers per second. This speed is what keeps the Earth in orbit around the Sun, and it's also what keeps the other planets in our solar system in orbit around the Sun. But why does the Earth have this speed in the first place? Well, it turns out that the Earth inherited this speed from the Sun when it was born. You see, when the Sun was born, it was surrounded by a giant cloud of gas and dust. And as the Sun began to collapse in on itself, all of this gas and dust began to spin around the Sun. And this spinning motion gave all of the objects in the solar system their orbital speeds, including the Earth. So the Earth has its orbital speed because of the Sun's gravitational pull. And the Sun's gravitational pull is what keeps the Earth in orbit around the Sun. But there's another really cool thing that happens here. You see, the Earth is constantly falling towards the Sun due to the Sun's gravitational pull. But because the Earth has this orbital speed, it's constantly missing the Sun. In fact, the Earth is actually falling around the Sun, and that's what makes it appear as though the Earth is going around the Sun. This may sound a bit confusing, so let's take a look at it step by step. When the Earth was born, it had no orbital speed, which means that it would just fall straight into the Sun. But because the Earth has an orbital speed, it falls around the Sun. If the Earth didn't have an orbital speed, then it would just fly off into outer space. So the Earth's orbital speed is what keeps it in orbit around the Sun. And it turns out that all the planets in our solar system have orbital speeds that keep them in orbit around the Sun. Now, you might be wondering, if the Earth is constantly falling towards the Sun, why don't we feel it? Well, that's because the Earth and everything on it is falling towards the Sun at the same rate, so we don't feel it. It's like being in an elevator that's accelerating upwards. You don't feel your weight because you and the elevator are accelerating at the same rate. So that's how the Earth goes around the Sun. It's a beautiful example of physics in action. Thank you for watching, and I hope you learned something new. If you did, please hit the like button and subscribe for more videos. And if you have any questions, feel free to leave them in the comments below. We'd love to hear from you. And who knows, Maybe your question will be featured in our next video. So keep on thinking, and we'll see you next time.